Be part of this discussion. From the looks of the people in the room, and most of you who I actually do know, this should be very animated and interesting. So we can have more of a discussion than me teaching, because I think a lot of you already know some of these problems, but we're going to have fun in the process. So for those of you who don't know me, my name is Norman Kirchner. I am an RF systems engineer at National Instruments. So anything RF related, you can come talk to me or one of my cohorts. I am effectively a grunt, and we're going to talk about HALs today, specifically the problem I call HALitosis. Quit writing hardware abstraction layers that stink. So you know what I was thinking? I was excited about this. I've been thinking about this for over a year doing this presentation. I came up with a name first, and then I was like, I got to come up with a topic around it. But the basic idea is that I was super duper excited. This is going to be like Christmas. There was going to be slides. I was going to give cards to everybody at the end of the whole thing. I mean, there was supposed to be code delivered. I mean, it was kind of epic. Unfortunately, the abstraction failed. I developed all my content on a mind mapping software that is in the cloud. My browser and the company Mind42 created an abstraction layer for me that made me completely unaware that I actually was working in the cloud and didn't have any software on my computer. It was a beautiful abstraction. Until their site went down for maintenance and stayed down while I was trying to work on my presentation. So just a very interesting realization along the way. So the presentation changed a little bit, not as many goodies and Christmas presents. So in the end, really, it's all good. We're going to get through it. We got an agenda. We're going to get through things. So we're going to go through effectively a basic state of the union. I travel around a lot. I see a lot of customers. I see a lot of customers' code. I've got a lot of thoughts on the matter, so we're going to talk about where things are currently at. Come on in. Seats up front everywhere. We're going to talk about some root causes for failure in the process of thinking about this. Why have we ended up with this problem? Why do we have hardware abstraction layers that stink in the first place? So when good, how go bad? Talk about why and how do they actually get to that point. How we can think about the problem. Hopefully you will agree by the time that we get there that there actually is a problem and we're not just delusional about this. And we'll talk about how we can think about it a little bit differently. And then also talk about and actually show some of those different approaches as well. Not as fleshed out or ready to hand you on a USB stick as along the way, but we got some stuff. So we're going to start off with some basic nomenclature. So we're going to talk about abstraction. What is it? So as per the wiki definition, it is the process of separating ideas from specific instances of those ideas at work. So as you can tell, that is a pretty abstract definition of abstraction. So a hardware abstraction, as per me, for test and measurement automation, the elimination of the amount of effort required to interchange one test instrument with another in a test system. So for me, I'm keeping it very much along the lines of test and measurement with this. And the idea is that really, in an ideal world, a HAL should just absolutely eliminate any knowledge of, hey, I'm going to go from this instrument to that instrument. Somebody developing a test, somebody developing a test solution, a test system, it should just be a no-brainer, a zero-op, if you will. But I would say that the reality of a hardware abstraction layer is a software infrastructure framework which allows a manager to say that their organization is increasing its return on investment on software reuse. It ends up giving the test software engineer endless headaches and challenges while concurrently making the end test engineer frustrated to no end because they cannot use their instrument like they're used to and have to go to the software engineer for any changes in their test. So I don't think that's going to make its way into Pumpkin Wagnalls or into Webster's anytime soon. But we'll talk about where some of this information is going to end up. But I don't know if too many people would necessarily disagree with that, or at least say that they've never seen that ever happen if you've done a hardware abstraction layer. So one thing that I have noticed as well is that HALs are trending. There are more people who are either taking the HALs that they've created in the past and rethinking how they've ran into problems. They've had stinky HALs. They've recognized that they have odor problems, and they're starting to redo it. Or people are starting to create them from the very first go-around. They're seeing the postings on NI.com and other places. Some of these are postings from 2009, 11, 13, 12, all the way from Autotest.com, IEEE, and more stuff on NI.com. One thing that I don't have on here is definitely the dominance that NI has in the hardware abstraction realm. Actually, let's do this. might actually be in this open. Nope, never mind. Do this. Okay. So, what? So they're trending. Why are they trending? Because HALs bring with them, or the concept of a HAL, promises. Promises of mitigating hardware obsolescence. There's actually the white paper on NI.com that talks all about mitigating hardware obsolescence and how HALs can solve this problem. There's also the pull and the draw of, hey, I'm going to have more reuse. Not realizing that the way that if you're not careful up front, you'll turn that reuse into refuse. There's the increased return on investment. So I have developed an entire test system, but hey, I've got a new piece of hardware, or somebody else comes in the group and they want to do something different. Things should be easier, right? Wrong. To share the code from validation to production. This one brings me no ends of chuckling inside when I hear people talk about, oh yeah, this is just I can take my my test software from design validation, and because it's using a HAL, it should be able to go to production line, right? No. Unfortunately, there are unique ways of calling code and calling test instrumentation, performing tests that are trade-offs, and they exist. And HALs don't abstract you from different ways of doing things. Supposedly, countless ways to interchange instruments for whatever the next greatest thing comes out. Simplifying debugging through things of simulation, another draw behind this that has a lot more complexity than what it is. And weather the tide of change. Really just, whatever comes at it, we're going to be able to solve world peace. But the reality is that in all of these scenarios that I've seen, there's something that stinks in the air. All of these HALs have problems somewhere along the road. So we're going to get down, I'm going to give you some examples. Starting off with the mother of all you know. So there was a customer once upon a time, this is story time folks, hope you enjoy that. There was a customer once upon a time, and this customer had a radio. And that radio had 5 commands. And that radio, somebody put more commands on the radio. It turned into tune frequency and set output power level and do this and do that. The next thing you know, there's another radio that had the exact same set of commands, but 5 ones extra specific for that radio. And so what did they do? They took that enumeration and they added those extra 5 things to it. And then the next radio came along. And the next radio came along. And the next radio. And some of the radios didn't have any of those commands, but nobody paid attention to those commands. But they just kept adding and adding and adding. And this customer believed that they had a hardware abstraction layer along the way. In some senses of the word, you can say that they did. In other ones, not exactly. You weren't being abstracted from the fact that there were multiple pieces of hardware that could be communicated to, even though you didn't have them on your system. They might not even be produced anymore, but they were afraid to change the test software to remove those code calls at all. Another wonderful little story of failure, unfortunately. $100,000 HAL trash. Customer got an line script. Maybe some people from in this room right now. I'm not sure. The hardware abstraction layer and the test system was put together, very clean code. Nice front panels. There's a test sequencer. Didn't use test stamp. We're just going to click through the measurements. It was fine. But then they wanted to take that system, that code that was supposed to be doing everything, hardware abstraction layer, right? And put that code base on another computer that had different hardware, right? Hardware abstraction, should be cool. And then run that system with that other hardware. I'll show you what happened. I'm going to go ahead and open up class hierarchy here. Very simple. There's any dang instrument class. There's the oscilloscope foo class, the power supply bar class, and the DMM class. Right? So this is the system that was put together for the one customer. It was great. So then, that everything worked. VI wasn't broken. Just went through to the knit, configure ARM, so on and so forth. Nothing grandiose. And then they say, hey, you know what? There's a really cool other oscilloscope that we have. It's got way more features that we want to have in System A. So let's go ahead and add that sucker in here. File, Magic Mega Oscope. All right, so now you see view, class hierarchy, boom, magic mega oscope, we're good to go. Everything's happy. Then, what ends up happening is this magic mega oscope, if I'm not mistaken. Nope, that's not the one. Ah, yes, sorry, it was the original oscope. Has a .NET ref num in it. Because that one has a driver associated with it. It's not skipping, right? It's a .NET driver for that original oscilloscope. So the next person comes down the road, Sammy Joe Sue, and he, she, it decides to go and take that test code and put it on the other system that doesn't have the regular old oscope. It only has the magic mushroom oscope on the new system. So they don't have the driver, that .NET one installed. So let's go ahead and just simulate that real quick. All right. So we're going to go ahead and close this guy down. So we're going to go ahead and get rid of that .NET reference, right? But that's okay, because that .NET reference isn't really needed with the system that doesn't have that other piece of hardware, right? We're abstracted from the hardware. So why is it when I open up another project that doesn't reference that hardware, am I getting problems on it? Because I still have that class flat on a block diagram. Exactly. So let's go ahead and cancel and see if I run into issues with this. Oh, there it is. So I'm just going to go ahead and browse and show you the basics of the app. So they ran up into a situation like this where you ended up all these different errors, things talking about class dynamic dispatch. The end user wasn't capable of actually dealing with these errors, but the basic idea is, as some people have recognized, even though I have a system that doesn't have that specific oscilloscope on it, I have that class loaded in memory. That class being loaded in memory, even though I'm not going to use it, forces every class to be runnable. Now, there's good reasons behind that, but unfortunately, it locked up and it shut down the entire rest of the system just because that one driver that they weren't going to use was force loaded into memory. And so when you do an action like this, where you have a class and it's going into these are all any dang instrument calls, these are abstract calls, but because I have statically placed constants on the block diagram, it forces those other ones to be in memory. So $100,000, the reputation of that alliance member, the reputation of LabVIEW was all marred. Another one, abstract-ish type of methods. So this, ideally, let's just go ahead and simplify this. It's down out of the way. Let's go ahead and ignore these. This is a method that takes in range and measurement time and spits out a waveform graph. Simple enough, right? Any instrument that can call this method should take in those things and spit out of that. But the problem is, what we often end up doing, or what I've seen multiple times, is on the connector pane of that very VI that's supposed to be truly abstract, right? I'm referencing specific instruments on the connector pane itself. Not only does this go into the problem of forcing these type definitions to be loaded in memory, which was highlighted in the previous issue with the driver, we also have a situation where, hey, am I using this instrument or the other instrument? Declaring that there are only two instruments capable of being run with the hardware abstraction layer. That's not abstracting you from instruments, that's locking you in. You're either using this one or that one. And let alone, even if you did this, hey, I want one VI to take in multiple different types of configurations for multiple different specific instruments, you could fill up the connector pane very, very quickly with 5 individual instruments with their 5 unique clusters and going on. You can see that as well. Ace of base units. This one, oh, this one. Oh, this one. So, let's go ahead. So this is a big one for me. So I have an abstract call down here. But the units going into that VI are in terms of megahertz, hertz, and kilohertz. 3 different base units. What's the right way to say that? 3 different. What's that? 3 different. Well, they're the same SI unit, a different order of magnitude on the units, right? And so it's all fine if all of a sudden my expected frequency is at 314.59 megahertz, cycle rates at 128 hertz. My frequency offset's at about 10 kilohertz, right? That's obvious. No, big deal. That's what the instrument had. The instrument's API had those. What's the problem with that? Well, what happens when all of a sudden your frequency offset is 100 hertz? 100 millikilohertz? Or you want to go up into, say, 26 gigahertz? 26 kilomegahertz? There you go. 26 kilomegahertz. You can see the confusion. And if you're like, oh, well, he's using the suffix on there. Yeah, good luck with those too. So that's 22 hertz, that's kilomegahertz, which is a gigahertz. You laugh, but this is what we see. You know, it is sad. It's funny because it's true. But all hope is not lost. Let's keep going. This seems to be fun. There's another one. One cluster to rule them all. Who hasn't done this? Stephen Mercer in the back. That's fine. You prefer to see anyways. So, but yeah, this is a scenario that I think a lot of us, after engineers in the room, have all seen. Let's just take every possible configuration for every instrument we want, put it in one cluster, and in the software, we'll just use unbundle by name. That'll solve all the problems, yes. Right? We'll just unbundle by name. Except when you go and you try to put this in the test stand. Oh yeah, I'm doing it. Yep. Oh. It hurts. Oh, it hurts. Don't do it, Norman. Don't do it this time. Oh, wait a minute. Which one am I using? How do I tell the DI even which one? Oh my gosh. Yep, that's the. Yep. When I first started working, I can air this because it's not necessarily customer I'm working. When I was first working at Texas Instruments, we had this very scenario, and one of the very first things I did there was get rid of this scenario and start calling things dynamically because of this problem. I mean, it's just absolutely massive. It's difficult to know, it's hard to manage, and also, once again, it forces every single driver to exist on the system for any instrument that exists, which is just not right. Close that, hide that for all eternity. Okay, so this is another interesting one, the idea of inheriting technical debt. I don't have a clever VI to illustrate this one. But very often in the process of talking about hardware abstraction layers, what to do, where to go, what's the right way to kind of go about this, the most frequent knee-jerk reaction that makes me want to knee-jerk them right back is you just go ahead and you extend the class. Oh, you just want another input to that function? Just extend a class. It's not necessarily that it's wrong. You can extend a class and get a lot of extra capability and functionality out of it. That's part of the ideas of classes. But is it right? Should it be your knee-jerk reaction? I would say absolutely not. There's a variety of books. One of it's the purple and white one, Object-Oriented Thought Process, I think it is. Then there's also another one, Hardware Head-First Design Patterns. I think it's the head-first one that talks about if you will hang yourself by your inheritance. You You will absolutely, if you just say, I'm going to keep extending. Oh, I need another feature, just extend it, because then what happens when you've extended all the way out to here, but the feature that you've extended out over here is needed on this branch of the tree over here. What then? That should have been handled more likely by some kind of composition of classes, and just a better thought out design along the way. So it's that idea, every time that you just say, I'm going to inherit, I'm going to inherit, I'm going to inherit, you're inheriting technical debt that you're going to have to pay for later down the road when you need something else. And my personal favorite, is Gerardo in the room?
Yes.
The magic delay theory. So,
every single time.
I don't know if it came directly from Gerardo. He's a fellow RF systems engineer, but his definitely his face should be up. I didn't even think of that. Don't worry about that one later. Anyway, just give us now, everyone. So,
Hey Brian,
the magic delay.
there's your solution.
So the magic delay theory is what happens when you're trying to call hardware, and you send one command and you send the next command, and the first command hasn't finished processing, right? Because all of a sudden it doesn't work. So what do? Well, you just sit back and the magic delay theory, 250, 500, 1 second, drops. The delay is all over your code, and before you know it, your code works, right? Right? Until somebody else tries to use it, or better, even worse, I suppose. The worst scenario, and how it has relevance to us here, is this. You have this wonderful, cleanly, with the new GDS Goop Development Toolkit suite in LabVIEW now, free on VIPM. Created all these classes that are truly abstract for any dang instrument, but because one of your instruments needed the delays, you put them at this level, forcing every single instrument to pay the penalty of 1. And guess what happens when PXI goes in there? Well, we don't need no stinking delays. I got to try to convince somebody to rewrite their test code because I want to actually I want to show them how fast they can go, but if I just try to fit into their HAL, fitting into their HAL fits into their fat in terms of their test time. I don't want fat suits. All right. So, perhaps you've come here seeking an answer. Well, I have good news. We're all looking for that silver bullet. I know the answer. It doesn't exist. I'd love to. I was really, really hoping in the process of investigating this presentation, going down, trying to come up with ideas, and I was like, got it. But there was no one answer. That's the one thing that I was sure of. I think it has to do with this. So Joel on Software, it's a blog post that came out a long time ago. I don't know if he's still posting or not. He's not really close enough. But he has something called the law of leaky abstractions. Because all non-trivial abstractions, to some degree, are leaky. He uses even the idea, well, actually, the key example of this is the example that I let out. That abstraction from the fact that I didn't actually have my document on my computer, nor a program that could read that document on my computer, worked perfectly until it failed. And then the abstraction of the fact that there is an internet and I have no software on my computer leaked through, just by the sheer act of their servers going down. So what happens in our code when we've got leaks in our software? Well, all those things that I listed, when you have to put a delay in, when you have to put an instrument-specific input into a function, or maybe you've got 3 different pieces of hardware, each of them send out different ways of formatting their cluster, so you have 3 different cluster outputs on the abstract call. Or you have to have your abstract class have instrument-specific calls that everybody else just ignores. Each one of these things are small leaks in your system that unfortunately can add up to something quite a bit more substantial. Eventually, to the people in this room who have been taken part of, or in the process of redesigning their hardware abstraction layer, this is why. Because you are like that poor guy in Florida that was, 2 years ago, sucked into the ground from a sinkhole underneath his bed. What was the thought going? It was like Freddy Krueger's. So one more instrument. We're clever test engineers. We got this one, right? No problem. We got this one covered. We're going to do it. So we hold it together. We do everything that we can to hold on to dear life, hold the system together, do whatever you need to so that you don't have to rewrite the entire infrastructure. But the sad truth is at some point in time, it's too much. it's untenable, and there's nothing left to do but kind of start over. So, where did all of this go wrong? These are things to take back to your organizations, and also when you speak to your customers as well, they're eager to start on how to put some more forethought up front. Because these are just those very simple things that happen, right? I added another instrument to the station. But wait, is that instrument's model of operation the same? Can you set that frequency, set that marker, set that power level, and have it actually work? Or does it have to go in the opposite direction? Well, if you reverse the order of the abstract calls, does the other instrument still behave appropriately? Simple things, just they changed the firmware. So the exact same instrument, but they gave a new firmware version. Maybe it doesn't need the delays, or maybe it needs longer delays. So you start dropping more magic delay fairy all over the place until things work. The new guy joined the team. Here's an interesting one. He had no idea that you weren't supposed to step here and step there and go there to try to get across. He just happens to step on the right pads, and next thing you know, he gets shot in the neck with a poison dart. Test engineering needed a very specific feature. So even for the best, this is kind of a really realistic and benign but true leap, where the test engineering, everything's cool with the HAL, it's all good, it's all good. Using this, using that, using PXI, using GPI base, whatever. But then there's like one feature that one test engineer needs for that one thing. How do you respond to that request? Do you allow it to leak all the way through? In some cases, as the law says, they are all eventually leaky to some degree. So some of it's acceptable, some of it isn't, but that's a very real one. We wanted to try to use PXI. This is one that has plagued me since before actually coming to work at National Instruments, when I was actually working at TI beforehand, where all of a sudden we had a hardware abstraction layer, but it didn't fit the PXI model well. So when Craig Clausen and Gerardo actually came to TI to actually work with me when I was working there, they're like, well, we can't really get PXI in your system to show you your test time optimizations because you fashioned it very specifically off of the way that a box instrument behaves. And if you want to do more, if you want to see more performance, you can't have your hardware abstraction fashioned based on a specific piece of hardware, namely a box. Another part of the organization wants to reuse the code. This one I've heard a lot, where, hey, we're over here in, somebody give me a state? Iowa. Okay, there we go. So we got a team over here in Iowa. Everybody's happy hunky-dory, developing their code. All the engineering, production, test engineers, they've all created their HAL, everybody's using it. And then the team over in Oregon wants to use it. They're like, hey, you got a HAL. We got hardware. We need HALs, right? Sure. So they give them the code. How hard is it for them to bring that hardware abstraction layer up and running? How many drivers do they need to have installed? Did you give them even installers along the way? That process of transferring and giving your HAL to another organization is a true litmus test as to how functionally contained your layers actually are. Software needs to go into production. It's very rarely straight, and we're going to talk about that a little bit. Or some darn systems engineer came in and started telling me I was doing it wrong, and he would have gotten away with it too, and his manager would have found out it was meddling kids and distracting the dog. Some people do cats. So there's nobody to blame but ourselves in this one. I'm sorry. I don't mean to put guilt on you, or maybe it's the guy or girl before us. But a couple quotes, quotable quotes along these lines. Something to keep in mind so that when we start developing these systems, we can think about them hopefully in a clear fashion that will come up with some of those answers, not the silver bullets. One man's abstraction is another man's obstruction. Test engineers are not necessarily software. Actually, I'm going to pull up, there's a great quote. The sales guy sent it to me. We're trying to show them PXI hardware, show them all the benefits of doing this. You know, PXI isn't the only way to do it, but obviously it's pretty valuable. Come on, there we go, maybe. I'm only going to do this in a second more. There he is. Bingo. So, here at XYZ Company, we test engineers are instrumentation engineers. We'll program for automation, but most of us aren't software developers. So what do you think that person's mentality is when you give him a piece of code that he's supposed to run, and all of a sudden you've got to teach him OO? Or you have to teach him how to actually get through the layers so that he can actually see the string parsing that's happening to format something to go over VISA to some Skippy-based instrument. how painful is that? Before, it just used to be he used to go into a VI, see the command, realize he put an extra comment in there for some reason, and he's off to the races and fixes it. This one is actually from Stephen Mercer. The minute that I was presenting this, I was giving this concept to an internal user group at NI, and when he said this, velvet ropes opened, champagne started flowing from the ceilings, it all locked in. When designing an abstraction, no more distracting slides. When designing an abstraction, knowing one is worse than knowing none if you don't have all. I'll say it one more time. When designing an abstraction layer, knowing one instrument is worse than knowing no instruments at all if you don't know every single instrument that you're going to work. Because normally what ends up happening, and we're going to talk a little bit more about it, is you'll start with that one instrument that you know. Guess what that API will look like when you're done? Carbon copy of that one instrument's API. And every other instrument's going to have to pay the penalty. We'll get to that in a minute. Another one from a famous philosopher, Sunscript. Twitter hashtag Scripting Ninja. Too careful of cracks in the sidewalk, the walls quickly meet your head. Focus your distance to walls, and sidewalks rise to crack your face. The person that works with their hardware abstraction layer, this all makes sense. Don't worry, it's all going to come together here. This is good stuff. The person that writes their hardware abstraction layer is only focused on the instrument they have in front of them. Going like this. All right, I'm writing HAL. It's going to take me that way. I'm going to make sure I'm going to get this one right. Soon enough, the head goes into the wall. However, there's the flip side to that too, where if you try to solve every problem, I'm going to see out into infinity every possible instrument that could ever be run on this station, every possible mode of computation, every system diagram, you name it, it's going to handle it. You'll spend all your time focusing out there, and you'll just stumble left and right and never get anything created to start with. So this is highlighting the fact that the reality is we've got to find a balance between these two. We have to, I know for a fact we've got to look beyond ourselves. But I know for a fact that if you spend all your time not coding until you solve the everlasting problem, you're never going to get started. So, what are the root causes behind this? Well, the design, as I mentioned, you have one instrument in mind, one instrument flow. Now that could be because you're not familiar enough with how other instruments of a similar class are talked to. They behave. Things that might be different between an individual instrument and a different instrument. And that's okay. You have a strong desire to create this hardware abstraction, you have to start from somewhere. Hopefully, at the end of this presentation, I'll direct you to a place where we can expand the conversation on that. But the reality is that you've given that one instrument a free ride. That one instrument has just sailed into your hardware abstraction layer without any kind of problem. The reality is that everybody should have to pay a little bit of cost. Because at the end of the day, if you do this, that one gets a free ride. Every other instrument has to pay a penalty. And who ends up paying the penalty, the worst at the end, is the user of your API when your hardware abstraction layer leaves. And also you can't get other hardware into it. This goes directly into the idea of end users implementations were not prioritized. Did you actually ask your user, how do you want to actually talk to your power supply? Do you want it to just be read from a configuration file and said, go, and done? And did you just give him 28 different discrete little VIs that he has to drop on a block diagram? Did you even ask? Did you take it on yourself to even think along those lines? Maybe yes, maybe no. But so when I see some of these failures, it's because those questions weren't asked. Coupling the software design to a specific type of test station or hardware stack-up, this is a bit of a different flavor from the beginning one, where, hey, I'm going to create a hardware abstraction layer that's going to do this type of test. But then you expect more from it later down the road. It works great for this test. There could be even hardware abstraction. I've got a power supply, a function generator, a signal analyzer, a vector signal transceiver. I could swap things out, it's good. But the minute that it even goes to a different station, even in your same organization, it fails. So you have to, once again, think beyond your current need. Think about that next person. And then expecting HAL modifications to cover all abstractions. So the idea of hardware abstractions covering all leaks. If you have one layer of hardware abstraction, and you know that it's going to leak, what do? You just patch it, and patch it, and patch it. So think about this for a scenario. Imagine this for a second. You have a tarp tied by 4 ends, maybe over your campus. And it starts leaking in a couple different places. Not bad, not enough to tear the whole thing down, but it's really annoying. And every time you patch it, the duct tape comes off. Duct tape is coming off. But you're persistent. But keep patching. You don't do it. Or would it make a lot more sense to maybe take that other tarp that you've got? It's a little bit different. Maybe you can't handle the weight, but it doesn't need to, right? It's just a couple extra drips. And let that actually catch those other leaks. And direct that maybe into a bucket off to the side. Instead of sitting there for 2 hours while your fiance complains about drips in the tent, trying to patch it left and right. Don't be afraid of using that extra layer. So this is a diagram. If you see the white paper on how to mitigate software obsolescence using hardware abstraction layers, Autotest in 2009, all rights reserved, copyright in terms of subject to change. This is a section that is often overlooked when people try to implement that very design. Because it comes with code, right? You, a manager, somebody else's manager, hey, go to this white paper, here's some code, great. And everybody just takes the code, and I see this as a class in LabVIEW all over the place. Very rarely do I see this be some kind of abstract class that can be interchangeable. You've gone from this what's supposed to be 2-ply paper down to 1-ply paper, and we'll just leave it to the rest of your imaginations as to what happens. It's 1-ply. It leaks through. So, an idea. How can we actually look at this slightly different? I say start with the results. If you're dealing with a scenario where it's kind of either it's a measurement, or whether it's a tuning strategy, or whether it's a validation strategy, I'm going to use the word strategy a lot, and we'll get to that in a minute. But I say, this is an example of a harmonics move. I worked with this panel in LabVIEW. We'll open up the code in just a second. What does the person using your code want the most? Why are they even dropping your code on the block in test stand or on a block diagram? They want the result. They don't want the measurement as much. The measurement might be inconsequential. If they could get the result without taking the measurement, do you think they take the measurement? No. So it's the result that is key. Now, for any given type of measurement, harmonics in this one, you can have a variety of different actual result quanta. Okay? Ideally, lasers, fingers. So we have the results for THD. Right? That is what harmonics is really aiming for. It's trying to let you know what is your total harmonic distortion. So that might be the least common denominator of THD. But that's not the only thing that you can get that you might care about even in the process of doing the THD measurement. Right? There are other results that are worthwhile. Hey, how much power is in your fundamental? What are the relative harmonic levels of the other subsequent tones? And also, do I actually want the traces over time? So this is something that's very interesting, depending on how you actually perform the measurement. Not necessarily, well, we're going to get to that in a second. But we start at the results. What does the user actually want to see when this is done running? And then you go, what do I actually know beyond that point? Right? So I know what hardware. No! You don't know what hardware you're going to use. You have to ignore the fact that you know what hardware you're going to use. You have to say, what do I know other than hardware? Well, I know something about the signal that I'm about to try to analyze, or something about the system that I'm about to try to analyze. In this case, I'm analyzing a signal, so it's kind of low-hanging fruit for me, but it has an input power, it has a frequency that it's at. How many harmonics out do I want to measure? The averaging count. What is the actual bandwidth of the actual primary tone frequency? And if it's not exactly at my set frequency, how far away do I search? Did you see anything in there? Well, most of the people in the room, I presume, are RF. But let's just put it this way. None of those parameters you will find, well, let's see. Not none of them. Well, I suppose there's a lot of parameters there that you would typically see associated with the harmonics measurement in RF that are not there. They were very explicitly excluded because they are settings very specific to how a box or another piece of instrument is about to perform the measurement. What that requires knowledge of what the box is about to do. and you don't want to know what the box is about. You want to be abstracted, ideally. From that point, you said what results I want. What do I know about the signal? Then, and that only then you can kind of pick which hardware you're going to choose from that point forward. So it's almost a filtration of this. Let me go ahead and actually open this code. So as I select, I change things that I care about. So once I have all those things selected, each one of those instruments, there we go. So the instruments in green are the ones of this is just randomly setting those values, by the way. But the idea is that based on what I actually want, not every instrument is going to be able to give me those results. It's just a fact. You can't take a real-time spectrum analyzer that has like an 800 gigahertz bandwidth or something like that just gives you a THD number and get all this other information. It just isn't possible with that box, or nobody's programmed it up into your abstraction. However, the NIVSA, or the vector signal transceiver, is capable of doing that. And hey, remember how I said none of these settings are associated with what the instrument is actually going to get set? Well, that's what the test engineer knows, right? They do know the instruments that they want to work with. Chances are they've validated how their measurements based off of just manually mashing buttons or running their own test code. So if you want to know that, well, by all means, give them a way to map that information back to truly what that instrument is translating that information to. There has to be this idea of, in the DAC-MX world, they call them wizards, I believe. Chris Chino in here? DAC, yeah, it's like, well, it's not the DAC assistants. No, this is underneath the hood of experts. You got me close. So they have these idea of experts underneath the hood of DAC-MX that go and say, hey, I got this hardware. I know enough about it to talk to anybody else. It's like, hey, I'm about to go ahead and deliver this to the user, and I know as much about this, and I know how to talk, and it's not going to be, you set this setting that goes straight to the user, or you set this setting that goes straight to the hardware. They coordinate between each other. It is a lot more complicated than just a straight switch statement in your code. It's the way a lot of people, that Bravo Foxtrot enum that we saw up front, that's all that was. That was their HAL. They just had a big old enum up front that said, hey, which one am I doing? Go ahead and do different things. But in order to try to prevent this leakage through, you truly do need to have a little bit more intelligence cooked into the system itself. So that's the idea of an expert. Something else to think about. So we'll go ahead and hold up on the strategy for a second. Okay. Who here does not like to use testing? Smatterings. Okay. That's fine. Some of you might not be in tests. Some of you might be more embedded in systems and controls, and that's going to be okay. I'm a test engineer. I'm never going to create another test executive in my life unless using this as truth. However, there are some features and functionality associated with test stand that provide some very interesting parallels to something that you yourself would actually have to code up in lab, presuming that you're lab users. So the idea is, so for those of you who are not familiar with it, this is test stand. This is me trying to measure a test that's going to measure out 5 harmonics, and for each one of the frequencies in an array, go ahead and get the harmonics. Very simple way of doing the individual testing. However, So there's no code underlying this, but what there is to highlight is that harmonics as a step now points to a discrete file. My test, my strategy that I want to implement right now, my process, my procedure, my measurement is linked to one file, one sequence file. And in test stand, a sequence file contains multiple sequences. And so what I'm proposing that people take advantage of in test stand is this easy interchangeability of saying, I'm going to choose this sequence or that sequence. So right now I have three very basic sequences. I've got my base harmonics measurement. I have one that's a stable strategy, and another one that's a performance strategy. Maybe it's going between a stable device under test that has good or bad firmware, and another one that's like ready to go full speed production. And so for the end user, ideally we've given them, sorry, not as big as I'd like it over here. We've given them a folder full of different strategies, measurements, tunes, validations. It's list of multiple. But imagine that harmonics and other measurements are up underneath there. So I've given them a palette, effectively, of measurements to go from, a higher level palette. That second layer. So the user goes through, drops it in there. And you can see it starts out linked to base harmonics. So my harmonic sequence file, which one of those sequences is in the sequence file? Now one thing that's kind of unique about this is that each one of those ways of performing harmonics has different inputs, has different outputs. It still has the same base inputs, the same common inputs that we were showing in that center section up there, but for the specific implementation, it needs a little bit of extra information, and also it spits out some extra information too, perhaps. Absolutely, please do. This is, I do not know, let's see, no. There's a short answer to that. No, sorry. The question was, is this my proposed solution? Not exactly, so I'll explain it. So let me just repeat the question real quick. So the question was, is that a custom step type that I dropped in test stand that it was made for a very specific piece of hardware? And the answer was no. No, it was not made for a specific piece of hardware. It was a custom step type, but not made for a specific piece of hardware. That's what I believe is possible. So we're going to get to that in a second. We can dive to it a little bit more. So yes, there's a lot of unanswered questions that go along with this. Remember that first three slides here about the presentation that crashed? The thought process is the user themselves can choose at edit time, it does not need to be runtime dynamic, which implementation they actually want to use. And you can see here, we stop at F1 search band. I don't know if you can all see that. Let me go to the up some. This stops at F1 search band. And then we've got a results cluster that comes out of it. This is for the base harmonics. This is choosing at edit time. These are edit time operations. So the idea is that you want to actually choose the way that you're going to perform your test, not at runtime. You will choose the way that you're going to perform your test based on the knowledge that you have of how you want your test performed, or the individual measurement. So the idea here, for those of you who are not familiar, I can select a performance strategy. If you caught, all those values are still mapped to everything that they were mapped to before, inputs, outputs, all those things. But now I have these new codes. New inputs to my individual function. In LabVIEW, it kind of has the essence of polymorphic VIs, but you're also not rewiring things in a block diagram. For me, the one thing that I've seen about code that gets really nasty is when people that aren't necessarily very good LabVIEW programmers start monkeying in the LabVIEW code. So I want to provide them, get them out of that world that they're just going to turn into a rat's nest and give them something maybe a little bit easier for them to create cleaner code. So underneath the hood of this, I'm proposing that you still call a hardware abstraction layer. The hardware abstraction layer is still called inside of the guts of this very specific stuff. So if I were to go into the sequence, my apologies for leaving it just like this, but the idea is that, yes, you'd have your individual HAL calls, you'd have your IV calls, and things of that nature being actually called at this point. All that I'm trying to do is give a way to have a different layer where it's selectable by the user as to how something is about to be performed. Give them that choice at edit time, make that choice at edit time easy for them to change without screwing up other code, and then kind of give a functional containment to actually where things are. And that idea of keeping everything in the sequence file, I think, helps facilitate, here's a strategy for performing a measurement. I want to perform INL and DNL. I want to do a diode curve. I want to do a strain gauge measurement. I want to test my microphone. Some of those are higher level than other ones. Some of those require maybe coordination with different instruments. But yes, please. It's not specific to the specific piece of hardware. At no point in time have I said it's a specific piece of hardware.
This is more of a measurement abstraction layer.
The idea of the test being portable and reusable is the fact that there's a harmonics.seq file. I can take that harmonics.seq file and point to it from any other main sequence. So now I've got totally brand new sequence file. And I have that, once again, that custom step type is a test stand kind of thing, but really it's just a pre-configured step, if you will. And that pre-configured step is pointing to a very specific file on disk. That very specific file on disk is the reusable file, that reusable sequence or harmonics file. And that harmonics file is the one that contains all the different strategies and ways to perform that one given measure. Does that kind of make sense? That becomes one of the abstractions. Yes. Yeah, so as was mentioned, the idea is this becomes effectively, I call it a strategy abstraction layer, because it's not always about measurements, but you can consider this one a measurement abstraction. Yes. Yes, this ends up being the configuration for that specific sequence, custom step type actually. So we have linked a very specific sequence file to a very specific step. So now they have an intimate linkage between those two, but that is reusable. And now we actually have the ability to go ahead and allow that, wherever it gets reused, that reusable component, to choose the appropriate hardware and settings and instrument based off of that. Every time that you put the harmonics measurement down and you drop it from the palette, it needs to be configured. I mean, I can take a given one. I don't know if let me just do this and see if it's answering your question. I could take this, which is already configured to measure 5 harmonics, and just as easily go here and drop it there, and this will still call that same sequence file. All that this step is doing is holding a configuration so that when I right-click on it and edit it, or when it actually runs at runtime, it has the necessary information. So I can't guarantee this is how big of a pitchfork or an axe this is against that wolf. I think it's got a lot of legs. I think, yeah.
So, I mean, what you're doing in test stand, I think you could do the equivalent in that.
Absolutely.
And you would have a base class for an artifact, and then you would extend that class ad libitum.
I believe so.
So at what point do you run into the same problem if you say, well, you just keep extending and extending and give the same whole hardware?
So the question ended up being is if you can do this in LabVIEW and you can run into the same problems like extending in LabVIEw, why won't we run into it here? Partially the reason is there's no way to easily extend this per se. There's not really an extension in the classic object-oriented sense of the word. So by staying in test stand, I've tried to decouple myself. I'm taking similar concepts that a sequence has output parameters and most of them are the same and only a couple of them are changing and it's easy for me to change which ones I'm talking to. But really I haven't really extended anything. I've just added a sequence to a sequence.
Also, just adding one more capability, right? You could decide to add a fourth sequence that.
Yes. Oh, absolutely. Absolutely. But I think that the ability to use test stand, well, there's two things. One, I didn't actually have to create any framework at all to do this, which is, I think, the draw for me in terms of trying to help people who want to do this kind of measurement abstraction without having to put together an entire framework. This might be an easy way for them to kind of step down there. Also, even as I started going down this, I realized there still needs to be some part of infrastructure around things to make sure that the configurations, that all that the sequences inside of the sequence file at least have all the same kind of common pieces of information. This does not just completely eliminate the need for some kind of framework, but it still lowers that barrier to entry, allows you to play around with it. Also, it gives the end user the ability to kind of create code and create test without worrying about the quality of LabVIEW code that they're going to create, possibly breaking something else. That's partially my big concern, is that I like the idea, and that's why I like test stand so much, because it allows me to enable test engineers who are not, hey Chad, yeah, well, if you were here for that quote, I think it may have actually come from him. But the basic idea is that I want to try to come up with an alternative solution that is just another way to kind of come at it. So I think we're running low on time. We are, so I'm really, really close to the end, so I'm just going to round off here. So you might have certain mixed feelings. You may have been very, very, oh, I never did that, and oh, I did that, and then you feel very bad. And so maybe you've done all these things, and you're very, very ashamed, and you would like to hide and crawl in a hole. Maybe you're extremely indignant about all these things. How dare you tell me that I've created my hardware abstraction bad with LabVIEW 2 style globals and so on and so forth. Who are you, stinky young man? And then some of you are maybe, got a point. Maybe there's some validity behind this. Well, one thing I can say for sure, I want this to continue beyond where we're at because I tried for a year to get around to figuring out how some of these things should flow and fit together. And based on time and everything, I didn't have enough. Also, I don't have enough creativity. I haven't done this enough. I know there's a lot of partners out there that have created these hardware. Maybe you figure out all this stuff. You figured that out a while ago. Share it. I know it's sensitive information. However, between Lava, the individual partners, NI, and the like, I want to band together to see how we can attack this bigger problem. Come up with some ideas so that the next jump down the road. Now I know that it's all about certain, services. You want that next guy down the road to screw up, so he has to call you in to help him out, right? That's how we put food on the table. Well, wouldn't it be so much nicer if that guy down the road actually created something really cool and wants you to do something even cooler instead of just cleaning up his mess? So where do we go from here? Big, massive QR code for those of you who like that kind of thing. I've created and just launched yesterday Abstraction Distraction on the NI communities themselves. This content will be posted up there. I'd like to try to continue to figure out how to answer some of these problems and have these ideas beaten up. A lot of the questions that came out today, they're good questions because I think they're good because I haven't figured out the answer, right? That's what you have to say, that's your idea. So I'd ask for, if you do the forum thing, I strongly encourage it. If you don't, if you do, maybe join on, add some thoughts about the presentation, so whether you loved it or hated it, either way. Check out the LabVIEW Tools Network Pavilion, and let's go get happy. It's happy hour. And also on the Signs of Community. And lastly, I'll stick around for questions afterwards, but thank you very much. I'll let you all go.